The last section of chapter 23 is about the alkylation of acetic acid, the Malonic Ester synthesis. So you have, in this case, a diester, okay, diethyl malonate, and it's a useful reagent for the preparation of acetic acid. So you can see here you have two possibilities of making substituted acetic acid. This is acetic acid. And of course, you were able to add two R groups to that alpha carbon. So we say that carboxylic acids cannot be alkylated in the alpha position directly. That's simply because it's an acid-base reaction. So the base reacts where it deprotonates, and you just produce a carboxylate. So we say here that the base removes proton on O, not the alpha position. Simply because this is more acidic, a more acidic proton. Now, another route is we can alkylate the corresponding ester and saponify, meaning also undergo a reaction of hydrolysis reaction. So we can use LDA, negative temperature, very cold temperature, do alkylation. And you get RCH2 added an R to this group. OET. And then, of course, you could have done hydrolysis. H2O heat, and then, of course, to protonate. So you could make it an ester. You can make it a carboxylic acid. So this is the hydrolysis portion. Yes, but there are drawbacks. It's that it's a more expensive reaction. LDA, and it's not as cheap as just using other raw material. Requires inert atmosphere techniques, better for smaller scale reactions, and of course the enolate is much stronger than the stabilized the enolate base than the stabilized enolate. Basically, what you get, as we discussed before, so you get more E2 product. So not a good replacement, not a good alternative. So then we can do, just like what we did before, which we can do what we did to the acetic acid, acetoacetic ester, and that is do the alkylation, hydrolysis, and then the decarboxylation. And then, of course, you can arrive at the product, the desired product. So in this case, we will start with the diethyl malonate. So let's begin. So step one, just use blue. You do the alkylation. So you're going to remove this. And of course, add a CH3. So the CH3 is going to replace one of these. And then what we do is the next step would be to hydrolyze the ester. Hydrolysis of ester. Once again, you can do acid base. You can choose either one you want. So I'll just choose acid in this case. And we're going to have to draw this out. Maybe we'll do it to here. Let's see. And of course, lastly, we do decarboxylation. And we will end up with CH3, of course, plus CO2. So we were able to add one CH3, one methyl group. Again, what you could have done before the hydrolysis is did another alkylation to add two methyl groups, let's say here. And that's it. And let's just write this as step 3.